Kevin, and today I will be explaining what recursion is. What is recursion? Recursion is when a function calls itself. When a function calls itself, that function is called the recursive function. Recursion is a very helpful algorithm and can solve many problems. For example, you can easily write a recursive function for generating Fibonacci numbers. Recursion can be used anytime there is a pattern, such as in a factorial function. Recursion is my favorite algorithm because I find recursive functions very fun to write. A factorial function can be made using a recursive approach. You can find the pattern in factorials, which can help you to make the recursive function. Every recursive function must also have a base case. A base case tells a function when it should stop calling itself and when it should start returning values. In this case, the base case is 1 factorial is equal to 1. When the recursive function eventually reaches 1 factorial, the function will start returning values. The factorial of an integer, n exclamation mark, is equal to that integer multiplied by all the integers less than it until 1. For example, 4 factorial is 4 times 3 times 2 times 1. Here, 5 factorial is 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. We notice that 5 factorial is equal to 5 times 4 factorial. We can do the same thing with 4 and 3 factorial. Both of them have 3 times 2 times 1 on them, so we notice that 4 factorial is equal to 4 times 3 factorial, and 5 factorial is equal to 5 times 4 times 3 factorial. This pattern can be used in a recursive solution. While doing a recursive problem, your first step should be to find the pattern. In this case, we can find out that n factorial is equal to n times n minus 1 factorial. Here's a diagram of the factorial function. As you can see, 5 factorial is equal to 5 times 4 factorial. 4 factorial is 4 times 3 factorial. 3 factorial is 3 times 2 factorial, and 2 factorial is 2 times 1 factorial. Here, 1 factorial is the base case. So we notice that 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2, which is 6. And then 4 factorial is 4 times 6, which is 24. And 5 factorial is 120. Here's an example of a factorial function implemented using recursion. Here, we have a function factorial. It takes in an integer n and outputs a long. First, we check if n is equal to 1 or n is equal to 0. If so, we've reached the base case and we return 1. Otherwise, we go into the recursive step and we return n times factorial of n minus 1, which is this pattern. Let's try something out. If we input 5, we get 120, which is the expected result. How do recursive functions run? Well, to understand this, it is important to know what a call stack is. A call stack is a stack of function calls, and a stack is a data structure where you put things in and remove things from the top. For example, a pile of books is a stack. You add things to the top of the pile, and you also remove things from the top of the pile. If you remove something from the bottom of the pile would collapse. When a new function needs to be executed, it is added to the top of the call stack. Once the program reaches the base case, it starts running the functions at the top of the call stack and removing them from the stack once it's done. This process is repeated until all the items in the call stack are gone. Here's an example. First, we call factorial of 5. And then factorial of 5 is equal to 5 times factorial of 4. Factorial of 4 is 4 times factorial of 3. This continues until we reach the base case. Factorial of 1 is equal to 1. Then we finish all the function calls and we can start returning values. So factorial of 2 is 2, factorial of 3 is 6, factorial of 4 is 24, and factorial of 5 is 120. Conclusion. Recursion is a very powerful tool and can be used to solve many different types of problems where there is a repeating pattern. Recursive functions always have at least one base case which tells the program when to stop calling itself. The call stack is a stack of function calls. When the recursive function calls itself, it adds a new item to the call stack. Once the function reaches the base case, it stops calling itself and starts running functions in the call stack starting from the top. Anyways, thank you for listening. I hope you enjoyed and now understand recursion better.